Touching circles. Activity 1. Take 3 collinear points x, y, z as shown in figure. Draw a circle with center x and radius xy. Draw another circle with center z and radius yz. Note that both the circles intersect each other at the single point y. Draw a line through point y and perpendicular to segment xz. Note that this line is a common tangent of the two circles. Activity 2. Take points y, x, z as shown in the figure. Draw a circle with center z and radius zy. Also draw a circle with center x and radius xy. Note that both the circles intersect each other at the point y. Draw a line perpendicular to segment yz through point y, that is the common tangent for the circles. We must have understood the circles in both the figures are coplanar and intersect at one point only. Such circles are said to be circles touching each other. Touching circles. If two circles in the same plane intersect with a line in the plane in only one point, they are said to be touching circles and the line in their common tangent. The point common to the circles and the line is called their common point of contact. Circles can touch each other internally or circles can touch each other externally. Figure 1. The circles with centers O and P touch each other externally at point T. Line L is the common tangent at point T. In figure 2, the circles with centers O and P touch each other internally at point T. Line L is the common tangent at point T. Remember this. When circles touch each other externally, the centers lie on the opposite side of the common tangent. Whereas, when circles touch each other internally, the centers lie on the same side of the common tangent. Theorem of touching circles. Theorem. If two circles touch each other, their point of contact lies on the line joining their centers. Given, two circles with centers O and P touch each other at point T. To prove, point T lies on line OP. Construction. Draw segment OT, segment PT and common tangent L at point T. Proof. Segment OT is perpendicular to line L. Segment PT is perpendicular to line L. Therefore, segment OT and segment PT are perpendiculars to line L at point T. As one and only one perpendicular can be drawn at a given point on a line, therefore lines OT and PT are not two different lines. They are one and the same. Therefore, points O, T and P are collinear. Therefore, point T lies on the line OP. Let's recall. Arc of a circle. A secant divides a circle in two parts. Any one of these two parts and the common points of the circle and the secant constitute an arc of the circle. The points of intersection of circle and secant are called the endpoints of the arcs. In the figure 1, secant L intersects the circle at point A and B. Arc AXB and arc AYB are thus two arcs formed due to secant L. If the secant passes through the center, each arc so formed is a semicircle. In the figure 2, line L passes through center O, intersecting the circle at points P and Q. Segment PQ is the diameter. Arc PRQ and arc PSQ are semicircles. In figure 1, line L doesn't pass through the center. Then the arc on the side of the center is the major arc, and arc on the other side of the center is the minor arc. Arc AYB is the major arc and arc AXB is the minor arc. Naming an arc. Usually 3 points are used to name an arc. The first and the last points in naming an arc are always its endpoints. In figure 1, arc AXB and arc AYB have endpoints A and B. The minor arc is named AXB and major arc is named AYB. In case if an arc is denoted with 2 points, then it is always the minor arc. Central angle. When the vertex of an angle is the center of a circle, it is called a central angle. In the figure, O is the center of a circle and angle AOB is a central angle. Like secant, a central angle also divides a circle into two arcs. Measure of an arc. To compare two arcs, we need to know their measures. Measure of an arc is defined as follows. 1. Measure of a minor arc is equal to the measure of its corresponding central angle. In figure, measure of central angle AOB is theta. Therefore, measure of minor arc APB is also theta. 2. Measure of major arc is equal to 360 degree minus measure of corresponding minor arc. In figure, measure of major arc AQB is equal to 360 degree minus measure of minor arc APB is equal to 360 degree minus theta. 3. Measure of a semicircular arc, that is of a semicircle, is 180 degree. 4. Measure of a complete circle is 360 degree. Congruence of arcs. When two coplanar figures coincide with each other, they are called congruent figures. We know that two angles of equal measure are congruent. Similarly, are two arcs of the same measure congruent? Let us find the answer by doing the following activity. Draw two circles with center C as shown in the figure. Draw angle DCE, angle FCG of the same measure and angle ICJ of different measure. Arms of angle DCE intersect in a circle at A and B. Do you notice that the measures of arcs AB and DE are the same? Do they coincide? No, definitely not. Now cut and separate the sectors CDE, CFG and CIJ. Check whether the arc DE, arc FG and arc IJ coincide with each other. Arc DE and arc FG are coinciding with each other. Arc DE and arc GF are congruent and it is written as arc DE is congruent to arc GF. From the activity we notice that two arcs are congruent if their measures and radii are equal. Property of sum of measures of arcs. In the figure, points P, Q, R, S and T lie on the same circle. Arc PQR and arc RST have only one point R in common. Therefore, measure of arc PRT is equal to measure of arc PQR plus measure of arc RST. Now, arc PQR and arc QRS have many points in common. That is, all the points on arc QR. Therefore, measure of arc PRS is not equal to measure of arc PQR plus measure of arc QRS. Theorem. The chords corresponding to congruent arcs of a circle or congruent circles are congruent. Given a circle with center O, arc APB is congruent to arc CQD. To prove chord AB is congruent to chord CD. Construction: draw segment OA, segment OB, segment OC and segment OD. Proof: measure of arc APB is equal to angle AOB. Equation 1. Measure of arc CQD is equal to angle COD. Equation 2. Arc APB is congruent to arc CQD. Therefore, measure of arc APB is equal to measure of arc CQD. Therefore, angle AOB is congruent to angle COD from equations 1 and 2. Equation 3. In triangle AOB and triangle COD, segment OA is congruent to segment OC. Angle AOB is congruent to angle COD. Segment OB is congruent to segment OD. Therefore, triangle AOB is congruent to triangle COD. Therefore, segment AB is congruent to segment CD. That is, chord AB is congruent to chord CD. Theorem. Corresponding arcs of congruent chords of a circle or congruent circles are congruent. Given a circle with center O, chord AB is congruent to chord CD. To prove arc AMB is congruent to arc CND. Construction. Draw segment OA, segment OB, segment OC and segment OD. Proof. In triangle AOB and triangle COD, segment OA is congruent to segment OC, segment OB is congruent to segment OD, segment AB is congruent to segment CD. Therefore, triangle AOB is congruent to triangle COD. Therefore, angle AOB is congruent to angle COD. Equation 1. Measure of arc AMB is equal to angle AOB. Equation 2. Measure of arc CND is equal to angle COD. Equation 3. Therefore, measure of arc AMB is equal to measure of arc CND. From equations 1, 2 and 3. Therefore, arc AMB is congruent to arc CND. Let us solve an example. In figure, points G, D, E, F are concyclic points of a circle with center C. Angle ECF is equal to 70 degree. Measure of arc DGF is equal to 200 degree. Find measure of arc DE and measure of arc DEF. Solution. Measure of arc EF is equal to angle ECF. Angle ECF is equal to 70 degree. Therefore, measure of arc EF is equal to 70 degree. Measure of arc DGF plus measure of arc EF plus measure of arc DE is equal to 360 degree. Therefore, 200 degree plus 70 degree plus measure of arc DE is equal to 360 degree. Therefore, 270 degree plus measure of arc DE is equal to 360 degree. Therefore, measure of arc DE is equal to 360 degree minus 270 degree. Therefore, measure of arc DE is equal to 90 degree. Measure of arc DE plus measure of arc EF is equal to measure of arc DEF. Therefore, 90 degree plus 70 degree is equal to measure of arc DEF. Therefore, measure of arc DEF is equal to 160 degree. Answer. Measure of arc DE is equal to 90 degree and measure of arc DEF is equal to 160 degree. Let's learn. Inscribed angle. In figure, C is the center of a circle. The vertex D of angle PDQ lies on the circle. The arms of angle PDQ intersect the circle at A and B. Such an angle is called an angle inscribed in the circle or in the arc. In figure, angle ADB is inscribed in the arc ADB. Intercepted arc. Observe all figures A to F in the following figure. In each of these figures, the arc of the circle which lies in the interior of angle ABC. The points of intersection of the circle and the angle are endpoints of that intercepted arc. That is, both the sides of the angle should contain an endpoint of the arc. In the figures A, B and C, angle ABC intercepts only one arc, whereas in figures D, E and F, angle ABC intercepts two arcs. Observe figure G. Arm BA does not contain any endpoint of the arc, hence arc is not intercepted by angle ABC in this case. Inscribed angle theorem. Theorem. The measure of an inscribed angle is half of the measure of the arc intercepted by it. Given, in a circle with center O, angle BAC is inscribed in an arc BAC. Angle BAC intercepts arc BXC of the circle. To prove, measure of angle BAC is half of measure of arc BXC. Proof. There arise three cases as shown in parts A, B and C of the figure. Case 1. The center is on the angle. In this case, join C to O. Triangle OAC is isosceles with OA is equal to OC. Let measure of angle OAC be equal to measure of angle OCA be equal to P. By remote interior angles theorem, measure of angle BOC is equal to measure of angle OAC plus measure of angle OCA. Measure of angle BOC is equal to P plus P is equal to 2p is equal to twice measure of angle BAC. Therefore, measure of angle BAC is equal to half of measure of angle BOC. But measure of angle BOC is equal to measure of arc BXC. Therefore, measure of angle BAC is equal to half of measure of arc BXC. Case 2. The center is in the interior of the angle. In this case, let D be the other endpoint of the diameter drawn through A. Let arc CMD be the one intercepted by angle CAD, and let arc BND be the one intercepted by angle DAB. Then, as proved in the first situation, we have measure of angle CAD is equal to half of measure of arc CMD, and measure of angle DAB is equal to half measure of arc BND. Therefore, measure of angle CAD plus measure of angle DAB is equal to half measure of arc CMD plus half of measure of arc BND. Therefore, measure of angle BAC is equal to 1 upon 2 into measure of arc CMD plus measure of arc BND. Therefore, measure of angle BAC is equal to half measure of arc BXC. Case 3. The center is in the exterior of the angle. Again, let D be the other end point of the diameter drawn through A. Let arc CMD be the one intercepted by angle CAD, and let arc BND be the one intercepted by angle DAB. Then, as proved in the first situation, we have measure of angle CAD is equal to half measure of arc CMD, and measure of angle DAB is equal to half measure of arc BND. Therefore, measure of angle CAD minus measure of angle DAB is equal to half measure of arc CMD minus half measure of arc BND. Therefore, measure of angle BAC is equal to 1 upon 2 into measure of arc CMD minus measure of arc BND. Therefore, measure of angle BAC is equal to half measure of arc BXC. Corollaries of Inscribed Angle Theorem. Corollary 1. Angles inscribed in the same arc are congruent. Given a circle with center O, angle ABD and angle ACD are inscribed in arc ABD and intercepts arc APD. To prove angle ABD is congruent to angle ACD. Proof. Measure of angle ABD is equal to half measure of arc APD. Equation 1. Measure of angle ACD is equal to half measure of arc APD. Equation 2. From equations 1 and 2 we get angle ABD is congruent to angle ACD. Corollary 2. Angle inscribed in a semicircle is a right angle. Given a circle with center O, segment AC is the diameter. Angle ABC is inscribed in arc ABC and intercepts arc AMC. To prove angle ABC is equal to 90 degree. Proof. Measure of arc AMC is equal to 180 degree. Equation 1. Angle ABC is equal to half measure of arc AMC. Therefore, angle ABC is equal to 1 upon 2 into 180 degree. From equation 1, therefore, angle ABC is equal to 90 degree. Cyclic Quadrilateral. A quadrilateral whose all vertices lie on the same circle is a cyclic quadrilateral. In the figure, point A, B, C and D lie on the same circle. Therefore, quadrilateral ABCD is cyclic. Theorem of cyclic quadrilateral. Opposite angles of a cyclic quadrilateral are supplementary. Given quadrilateral ABCD is cyclic. To prove angle DAB plus angle DCB is equal to 180 degree, angle ABC plus angle ADC is equal to 180 degree. Proof. Angle DAB is inscribed in arc DAB and intercepts arc DCB. Therefore, angle DAB is equal to half measure of arc DCB. Equation 1. Angle DCB is inscribed in arc DCB and intercepts arc DAB. Therefore, angle DCB is equal to half measure of arc DAB, equation 2. Adding equations 1 and 2, we get angle DAB plus angle DCB is equal to half measure of arc DCB plus half measure of arc DAB. Therefore, angle DAB plus angle DCB is equal to 1 upon 2 into measure of arc DCB plus measure of arc DAB. Arc DCB and arc DAB constitute a complete circle. Therefore, angle DAB plus angle DCB is equal to 1 upon 2 into 360 degree. Therefore, angle DAB plus angle DCB is equal to 180 degree. Similarly, we can prove angle ABC plus angle ADC is equal to 180 degree. Let's learn. Corollary of cyclic quadrilateral. An exterior angle of a cyclic quadrilateral is congruent to the angle opposite to its adjacent interior angle. Given quadrilateral ABCD is cyclic, angle DCE is an exterior angle of quadrilateral ABCD. To prove angle DCE is congruent to angle BAD. Proof. Angle DCE plus angle BCD is equal to 180 degree. Equation 1. Quadrilateral ABCD is cyclic. Therefore, angle BAD plus angle BCD is equal to 180 degree. Equation 2. From equations 1 and 2 we get angle DCE plus angle BCD is equal to angle BAD plus angle BCD. Therefore, angle DCE is equal to angle BAD. Therefore, angle DCE is congruent to angle BAD. Converse of cyclic quadrilateral theorem. If a pair of opposite angles of a quadrilateral is supplementary, the quadrilateral is cyclic. Given in quadrilateral ABCD, angle DAB plus angle BCD is equal to 180 degree. To prove quadrilateral ABCD is cyclic. Proof. There is one and only one circle that passes through three non-collinear points. Therefore, a circle passes through D, A and B. Let us assume that the fourth vertex C does not lie on the circle. Therefore, it lies either in the interior or in the exterior of the circle. Suppose C lies in the exterior of the circle. Let E be the point where line DC intersects the circle. Draw segment BE. Therefore, quadrilateral ABED is cyclic. Therefore, angle DAB plus angle BED is equal to 180 degree. Equation 1. But angle DAB plus angle DCB is equal to 180 degree. Equation 2. From equations 1 and 2, angle DAB plus angle BED is equal to angle DAB plus angle DCB. Therefore, angle BED is equal to angle DCB. Equation 3. But angle BED is an exterior angle of triangle BCE. Therefore, angle BED is greater than angle DCB. This contradicts statement 3. Therefore, point C cannot lie in the exterior of the circle. Similarly, it can be shown an assumption of C in the interior of the circle also leads to contradiction. Therefore, C cannot lie in the interior of the circle. Therefore, point C has to lie on the circle. Therefore, points A, B, C and D lie on the same circle. Therefore, quadrilateral ABCD is cyclic. Examples. 1. In figure, quadrilateral PQRS is cyclic. Side PQ is congruent to side RQ. Angle PSR is equal to 110 degree. Find 1. Measure of angle PQR. 2. Measure of arc PQR. 3. Measure of arc QR. 4. Measure of angle PRQ. Solution. 1. Quadrilateral PQRS is cyclic. We know that opposite angles of cyclic quadrilateral are supplementary. Therefore, angle PSR plus angle PQR is equal to 180 degree. Therefore, 110 degree plus angle PQR is equal to 180 degree. Therefore, angle PQR is equal to 180 degree minus 110 degree. Therefore, angle PQR is equal to 70 degree. 2. Angle PSR is inscribed in arc PSR and intercepts arc PQR. Therefore, by inscribed angle theorem, angle PSR is equal to half measure of arc PQR. Therefore, 110 degrees equal to half measure of arc PQR. Therefore, measure of arc PQR is equal to 110 degree into 2. Therefore, measure of arc PQR is equal to 220 degree. 3. Chord PQ is congruent to chord QR. Therefore, arc PQ is congruent to arc QR. Let measure of arc PQ be equal to measure of arc QR be equal to x. Measure of arc PQ plus measure of arc QR is equal to measure of arc PQR. Therefore, x plus x is equal to 220. Therefore, 2x is equal to 220. Therefore, x is equal to 220 upon 2. Therefore, x is equal to 110 degree. Therefore, measure of arc PQ is equal to measure of arc QR is equal to 110 degree. 4. Angle PRQ is equal to half measure of arc PQ. Therefore, angle PRQ is equal to 1 upon 2 into 110 degree. Therefore, angle PRQ is equal to 55 degree. Answer: angle PQR is equal to 70 degree. Measure of arc PQR is equal to 220 degree. Measure of arc QR is equal to 110 degree. And angle PRQ is equal to 55 degree. 2. In figure, segment RS is the diameter of the circle with center O. Point T lies in the exterior of the circle. Prove that angle RTS is an acute angle. Proof. Let segment RT intersect circle at point M. Draw segment MS. Angle inscribed in a semicircle is a right angle. Therefore, angle RMS is equal to 90 degree. Therefore, segment SM is perpendicular to side RT. Therefore, triangle TMS is a right angle triangle. Therefore, angle TMS plus angle MTS plus angle TSM is equal to 180 degree. Therefore, 90 degree plus angle MTS plus angle TSM is equal to 180 degree. Therefore, angle MTS plus angle TSM is equal to 180 degree minus 90 degree. Therefore, angle MTS plus angle TSM is equal to 90 degree. Therefore, angle MTS is less than 90 degree. That is, angle RTS is less than 90 degree. Therefore, angle RTS is an acute angle. 3. In figure, measure of arc NS is equal to 125 degree. Measure of arc EF is equal to 37 degree. Find measure of angle NMS. Solution. Measure of arc NS is equal to 125 degree. Measure of arc EF is equal to 37 degree. Angle NMS has its vertex in the exterior of the circle and intercepts arc EF and arc NS. Therefore, angle NMS is equal to 1 upon 2 into measure of arc NS minus measure of arc EF. Therefore, angle NMS is equal to 1 upon 2 into 125 minus 37. Therefore, angle NMS is equal to 1 upon 2 into 88. Therefore, angle NMS is equal to 44 degree. Answer: angle NMS is equal to 44 degree.